Okay, so I'm very excited for this talk, not least because Lucas has become sort of just a very dear friend of mine in New York, and it's very hard to overstate just how influential he's been on my own intellectual development, especially as a philosopher whose work has increasingly become more into linguistics. And I think probably most of us in this room have also had similar experiences with Lucas, just showing us how mereology and plurality works in natural language, among other things. Most recently, Lucas has been engaged in this very exciting project with Timothée Bernard, using, I think a lot of you already know about this work, using negative events and giving a unilateral truthmaker semantics. And I think this talk that maybe has negative events, or no, it doesn't. Okay, so there won't be any negative events, but it's sort of a continuation, I think, of this collaboration with Timothée. And so, Lucas, thank you for sharing this work on conditionals with us.
Thank you so much for this very kind and gracious introduction, Justin. It's been a pleasure working with you and the other organizers in the lead up to this conference. And I'm enjoying this conference very much so far. So thank you all for that. This talk is, as Justin mentioned, joint work with Timothée Bernard from Université Paris-Cité. The genesis of this talk was the kind of grand proposal that you write, where you promise that you're going to revolutionize everything in semantics. That grand proposal was what got me here, along with the support of Hannes and the MCMP. I'm talking about the Humboldt Foundation grant proposal. And the idea of that proposal was essentially to do, or let's say contribute towards doing for formal semantics, or rather doing for truthmaker semantics what Montague did for possible world semantics. That is to say, make it accessible to linguists, what Montague and Party and others did in that case, make it accessible to linguists, make it compositional, make it able to deal with constructions that go far beyond classical propositional logic. And of course, there's a lot to do. This is not possible for one single person to do, but it led me to think about what are the most, or what linguists would consider the most important abilities that a theory of natural language semantics should have. And then among these, a modality stood out. And within modality, there's been, of course, a lot of important work on modality in truthmaker semantics, and we've heard some of it yesterday. We're about to hear some more of it later in this conference. But one thing that does not seem, or did not seem to have been done, with a few exceptions, including a talk at the previous Truthmaker conference. Name of the authors escapes me. But in any case, what has received very little attention so far is the kind of theory of modals that includes a conditional modality. And I'm thinking specifically of something that corresponds to the standard Lewis-Katzer semantics for modals and counterfactual conditionals. And more generally, any semantics that has something to say about a conditional modality of the kind that's relevant, for example, for Chisholm's paradox. So in linguistics, the standard semantics for modals and conditionals is essentially that of Lewis and Katzer, which is to say that we have a set of possible wills that are taken to be ordered, or each possible will determines an ordering on these wills. You can think of it as a reprehensibility ordering in the case of deontic modals, for example. And then simplifying a little bit, that is to say, introducing what's known as a limit assumption, we then restrict the modals. So the modals are quantifiers over possible wills, as they are in ordinary Kripke semantics. But instead of quantifying over all accessible possible wills, we quantify only over the best of them. So this has various advantages. One of them being that it interacts well with Angelika Katz's restrictor analysis of conditionals, according to which the purpose of an if clause is simply to restrict, or to further restrict, in this case, the domain of quantification of a modal. And in case you have a conditional without a modal, then we assume, or Katz assumes, that there is a covert modal included. And so this essentially gives you a very simple and powerful and elegant analysis of a number of phenomena, including things like contrary to duty obligations, the avoidance of explosion, and other things. So it has a lot to say for it, the standard analysis. It has a lot of detractors too. In any case, from the perspective of someone like me who comes to this as a linguist, the most salient question is, what does Truthmaker Semantics have to offer when it comes to addressing the shortcomings of the standard analysis? And is there a way to do so while keeping the central insights and the spirit of the standard analysis? What I'm going to argue today is that yes, you can meaningfully and usefully combine Truthmaker Semantics with the standard analysis, or with something that keeps the spirit of the standard analysis for modals and conditionals. And when it comes to fixing the shortcomings, I will focus on two classes of phenomena. One class, broadly speaking, has to do with complex constituents in the antecedent, or in the consequent of a conditional, or in the prejacent of the modal. That's a proposition to which the modal applies. And another set of phenomena has to do with modal gaps, by which I mean situations in which neither a modal nor its negation is true. And to give you a sense of the kind of data that motivate my account, specifically the first kind of data involving complex constituents, let me just run quickly through a number of puzzles, many of which are well known and have many solutions, some of which arose in the context of my own earlier work with others, or are just generally speaking lesser known. There's, of course, Ross's paradox. Box P is classically and also in the Katz-Lewis semantics predicted to imply box P or Q, but we often feel that this is not a valid inference. This is called Ross's paradox. It also arises in the consequent of a conditional, and that's important to note because among the many theories, among the many accounts or solutions to Ross's paradox, there are many that do not generalize in an obvious way to the consequent of a conditional, if only because they are not straightforwardly compatible with an off-the-shelf semantics for conditionals. Simplification of disjunctive antecedents is famously invalidated by the Katz-Lewis semantics, but is often felt to be valid. And I will take it for granted in this talk that it is in fact valid. Free choice permission. Free choice permission is the classic puzzle of the way in which disjunctions under modals are interpreted roughly as if they were conjunctions, or as if they were conjunctions that distribute over the modal. In the case of free choice permission, that modal is a permission modal, or more generally, an existential modal. There is a similar phenomenon that I'm calling free choice from obligation. It's also been called the distributivity inference. It arises when it's essentially the same pattern, but when the modal is a universal modal. So from John must take an apple or a pear, we infer that John may take an apple and John may take a pear. Negative free choice is the fact that whatever non-standard semantics you might be, negative free choice is essentially a similar phenomenon that arises modulo De Morgan's law. And then, broadly speaking, the second type of data that motivates my account consists in modal gaps. So one kind of modal gap arises when we interpret a deontic modal as describing situations that involve explicit as opposed to merely implicit permission. And this can be thought of in terms of the classical distinction between strong and weak permission. So you have weak permission to do something if you are not under any prohibition against doing that thing. But you don't thereby automatically have strong or explicit permission to do it. In order for you to have explicit permission to do it, you need to there needs to be some kind of positive statement to the effect that you may do the thing in question, or maybe to the effect that you may do something that entails the thing in question, something along these lines. And an intuitive example is a hypothetical country in which it's neither explicitly permitted nor explicitly prohibited to smoke weed. And so in that situation, a sentence like Willem must not smoke weed would not be considered true because it's tolerated. But on the strong or explicit permission reading, the corresponding permission statement, Willem has permission to smoke weed, would likewise not be considered true. And I'm staying neutral here on whether it's false or neither true nor false. But so this is one kind of source of modal gaps. Another source involves disjunction under may, and this has been, many of these have been observed in the literature. I'm just reporting them. Imagine a scenario where there are two actions and one of them is permitted and the other one is prohibited. So smoking cigarettes is permitted, but smoking crack cocaine is not. So in that situation, the free choice disjunction sentence, Sue is allowed to smoke cigarettes or crack cocaine, is not true because it has a free choice inference, and that free choice inference is contradicted by the context. But the negation of the sentence is likewise not true. And one way to describe this is that, and it has been described as such, is that there is a presupposition to the effect that in a free choice disjunction sentence, the two disjuncts must have the same modal status. They must either be both permitted or both prohibited. And when they have different modal status, then neither the free choice disjunction sentence nor its negation are true. And a similar kind of modal gap arises when we replace the modal by the existential modal by a universal modal. The last piece of data, or the last pieces of data that I would like to put on the table go back to some work that Ivano Ciardelli, Linmin Zhang, and myself have done in 2018 in a paper called Two Switches in the Theory of Counterfactuals. It's in part an experimental paper, so these judgments have been thoroughly tested and replicated hundreds of times. The point I want to focus on here is that there are differences, that are essentially asymmetries on both sides of one of the De Morgan's laws in situations where you might expect a complex antecedent to distribute. It sometimes does not, or it distributes in a different way. So we have seen earlier that simplification of disjunctive antecedents, SDA, I've mentioned that it's widely felt to be valid, and I'll take it to be valid. But so what exactly does a conditional distribute to when you have a complex antecedent? This is essentially what we tested. And so take a sentence like 10a. If switch A or switch B was down, the light would be off. So SDA is the inference that therefore, if switch A was down, the light would be off. And if switch B was down, the light would be off. Okay. Now, there is a related inference that is invalid that I'm labeling double SDA or DSDA. Invalid inference would be, so if both switches were down at the same time, the light would be off as well. So that further inference is not valid. We tested this in a context where the light is on, just in case the two switches are in the same position. So either both up or both down. And in the actual world, they are both up. In the same context, we also tested what happens when you replace the antecedent by a negated conjunction, as in 11a. If switch A and switch B were not both up, the light would be off. So in this case, the antecedent has the same truth conditions as in the previous case. The only way for A and B to not both up is for one of them to be down. But even though the antecedent has the same truth conditions, it does not have the same meaning as in the previous case, assuming compositionality. And that's because the counterfactual as a whole has different truth conditions as a result of changing its antecedent. So the antecedents have the same truth conditions. The whole counterfactual does not. And so the antecedents cannot have the same meaning. So that's an argument for hyperintentionality in the propositional fragment of natural language. That's the argument we made essentially in the 2018 paper. I'm recasting it a little bit here. But so now, what is the difference in truth conditions that I'm talking about? Well, so if I tell you, and we again tested this, if switch A and switch B were not both up, the light would be off. Then, well, first of all, you conclude the same as what you concluded in the case of SDA. You conclude that if switch A was not up, the light would be off, and if switch B was not up, the light would be off. So I'm calling this simplification of negated conjunctive antecedents, SNCA. So that's exactly parallel to SDA. But now, get the further inference only in the case of negated conjunction that if switch A and switch B were both down, the light would be off as well. So this is the inference in 12. And this inference does not correspond, this inference is valid, but does not correspond to a valid inference in the case of disjunctions. It is a counterpart to the invalid inference that I labeled DSDA in 10. Okay. And so now there's many ways to look at this. The specific way we looked at it in 2018 was that we have to abandon the standard Katzer-Lewis approach to conditionals. And we developed our own semantics, which we called background semantics, which in conjunction with a fine-grained approach to meaning delivers or models these facts. The specific fine-grained approach that we used happened to be inquisitive semantics. We could just as well have used a variety of truthmaker semantics. We could, in fact, have done something along the lines of what I'm going to do today, as far as the propositional fragment of the language is concerned. What we said at the time was that not only did we happen to change the underlying semantics for conditionals, but we said that we have to. But there's no way we can rescue standard Katzer-Lewis. I'm here to tell you that I now think that we were wrong. In fact, I'm not the first to say so. In responses to our paper by various authors, including Katrin Schulz, Romoli, Santori, and Wittenberg, it was pointed out, in effect, that if you are willing to adopt a non-standard semantics for negation, as opposed to the classical semantics that we assumed implicitly in our own paper, well, then you have additional degrees of freedom, and these degrees of freedom allow you to maintain, or these degrees of freedom remove the specific argument against the Katzer-Lewis approach to conditional that we had mounted in our paper back then. So essentially, if you do something along the lines of, well, I'm adding now, if you do something along the lines of bilateral truthmaker semantics, and if you allow the clauses for disjunction and for conjunction to come apart in a way that only the bilateral approach allows you to, in a way that the bilateral approach allows you to do, well, then you can account for these data while maintaining the classical, or something in the spirit of the classical, the standard Katz-Lewis backbone semantics for conditionals. And this is what I'm going to do today. So now, in order to see the differences and the similarities between our approach today, so Timothe's and my approach today, and the standard Katz-Lewis semantics, I'm going to adopt a specific presentation of the Katz-Lewis semantics. I'm also going to adopt the limit assumption throughout, both for our own account and for in my presentation of the standard account. So take a set of possible worlds W, and then take what Katz calls a conversational background. Take two of them, in fact, F and G. So a conversational background is a function that asks for a world and returns a set of propositions, which in this case are, so a proposition in this case is a set of worlds. And now, essentially, the first background, F, which is called the modal base, provides a set of hard constraints, a set of propositions which jointly determine which worlds are accessible. So if you only had F, this would just be a roundabout way of restating standard Kripke semantics for modals. The new component, the component that distinguishes Katz-Lewis from Kripke, is the second conversational background G in Katz's formulation. This again maps each world to a set of propositions, but now these propositions are used to provide soft constraints, to provide a ranking over possible worlds. So roughly, one world is at least as good as another if it satisfies all of the propositions in G that the other world does, and then some. So you're trying to maximize the propositions in G satisfied. And the best worlds, according to W, are those that among the worlds that obey everything in F, obey as much as possible of the things in G. So the idea is that F gives you hard constraints. So if you're modeling deontic modals, F tells you something like maybe the nomological constraints, the physical laws of nature. And then G tells you what makes a world better than another one. So G is where we encode goodness in the deontic sense. That's the idea behind Katz's semantics for modals. Now, Katz's semantics for conditionals says when you start a sentence with if, the purpose of the if clause is to add the antecedent as a further proposition to F. So F is the modal base, a set of hard constraints. So essentially, we generate a submodality that only looks at those worlds, or where only those worlds are accessible that satisfy the antecedent, and furthermore, that are accessible according to the more general modality. And so we write F plus P for the result of updating F with P, or just adding the proposition P to F as applied to W. Okay. Now, what we're going to do to capture this behavior is introduce modal states. And the idea will be that two functions, call them anchor functions, a universal anchor function, a box, and an existential anchor function, a diamond. And these take two arguments. Each of them takes two arguments. The first argument is a state, and you can ignore that for now. It will only become relevant when we deal with conditional modalities, when we deal with conditionals. The second argument is a proposition, and that will be the prejacent of a modal or the consequent of a conditional. And so the idea is that, and the function returns a state. So the idea is that a box applied to a proposition P says that or returns a state, call it S prime, and this state is the state of P being necessary. And likewise, a diamond applied to P returns a state that is the state of P being possible. And of course, depending on the modal flavor, this may be interpreted as obligatory, permitted, and so on. Okay. Now, later on, when we will model conditionals, we will add a second argument, which I already wrote here. So the the first argument in order is a state, and this will be the condition. So conditional on this state obtaining, P will be said to be, will be said by the modal state in question to be necessary or to be possible, depending on the kind of modal function. So formally then, an anchor function is a function from states and propositions to states. The result of this function is then said to anchor this proposition. Or if we have the state as one of the inputs of this function, we say it anchors a proposition given that state. We will assume that there is a null state, which we write as S top. And so when we want to ignore this first argument, we just use S top. We then just say the output of this function anchors the proposition in question, period. Okay, so now when should a modal state anchor P? When should a modal state that's output by the diamond function anchor P? Well, what we will want for the system to do, and we are about to impose constraints to that effect, is roughly this: some best accessible world contains a truth maker for P. So we will continue to use accessible worlds, and we will continue to rank them, but our propositions will now be sets of truth makers. So that's roughly what we want as a first approximation. And as far as I've described the condition, this would give us something that will end up behaving a lot like Katz's semantics. But now, in order to make use of the added fine-grainedness that Truthmaker semantics gives us, we will add an additional condition, which is that every truthmaker for P, every way in which the prejacent can be true, is part of some best accessible world. And if you think back of free choice, right? You may A or B. So the idea here will be you may A or B is made true by a modal state, which obtains, just in case, first of all, some best accessible world contains a truth maker for the disjunction, so a truth maker for A or a truth maker for B, and this is the new part, every truth maker for the disjunction. So that includes every truth maker for either of the disjuncts is part of some best accessible world. This will give us a free choice inference and many of the related inferences. And then likewise, a modal state that anchors must P obtains just in case every best accessible world contains a truth maker for P. So earlier it said some, now we have every. And then furthermore, and we add the same exact condition as before, every truth maker for P, every way that P can be true, is part of some best accessible world. This will give us what I called free choice from obligation. You must P or Q, or you must A or B, therefore you may A and you may B. Okay, so this is what we want. I haven't given you the formal definition yet that will make sure this is the case. The formal definition is as follows. It restates what I have told you, and then it adds a little bit more complexity, which is the following. The condition that we have just added that says essentially every way the prejacent can be true, every truth maker for the prejacent is part of some best accessible world. Well, we're going to say essentially for every way the prejacent can be true, there is a world in which that way is true, and it's the only one to be true. So essentially, every truth maker is a part of some best accessible world that does not contain any other truth maker for the proposition in question, for the pre-JSON. Footnote, does not contain any other truth maker except for those which are part of the truth maker that we started out with, because these it has to. What we're doing here is something like the exaltification operation that we find in a lot of literature, including Aloni and Ciardelli 2013, for example, which was an inspiration for this part of the account. But also, it's also reminiscent of the literature on recursive exaltification in the linguistics, in linguistic semantics. So we add this extra condition. You can get a lot of the results of the talk, including an account of all of the data at the beginning of the talk, even with this this further wrinkle. So if you just use this bullet point and the bullet point on the previous page, you already get an account, but you know how it is. It's always good to have the fine print in case somebody raises objections involving sentences where the disjuncts are not logically independent and that sort of thing. So, okay. Now, I haven't told you anything about the language yet. I have only talked about frames. So let's look at the language. This will be a simple language that has a backbone of propositional logic on which we built or to which we add a few operators. We will start by adding a two-place conditional modal operator. And then we will introduce the ordinary box and diamond as shorthands for if true, then P, then must P, and for if true, then may P, respectively. This is, I think, a well-known move. Lewis does it, for example. We will sometimes use a material conditional. I'm using it as a shorthand, but it should be kept in mind that our semantics for the conditional is not based on the material conditional. So we will use a simple propositional language with propositional letters, with top, with negation, conjunction, disjunction, and like I said, these two-place conditional modals. And we will then say, given a frame of the kind I described, we will define a truth maker valuation for such a language on that frame. And the way we're going to define it is essentially what you would expect as a truth maker semanticist with a few changes and restrictions. Most importantly, perhaps, we will assume that every propositional letter has exactly one truth maker. So every propositional letter may be thought of as making itself true, if you will, or otherwise standing in a one-to-one correspondence with the truth maker. And the reason we do this, because this is quite a strong assumption, is because even as we want to get simplification of disjunctive antecedents to be valid, we want to invalidate inferences of the kind, let's say, if it was raining, the street would be wet. So for every truth maker for it is raining, if that truth maker obtained, the street would be wet. Why do we want to avoid this? Well, this has been discussed by Embry and McHugh and others in the literature, but essentially, depending on your ontology of truth makers, this gives you very unwanted results. So, for example, if you are tempted, as I sometimes have been, to identify truth makers with Davidsonian events, and if you assume that among all the raining events, there are some that only obtain in very remote worlds in which there is perhaps no streets or no gravity or no wetness, well, then you would not want to say that even for these very remote events, if they obtained, then the streets would be wet. So that's why we have only one truth maker per propositional letter and only one false maker also. So we then put our evaluations together with the frames I described. So we have a bilateral semantics, and and for comparison, I give you the corresponding clauses for classical valuation and for Katza classical model. And then we extend our truth making and false making clause from the evaluation to arbitrary, from the propositional letters to formulas of arbitrary complexity. And this too will be largely familiar to Truthmaker Semantics, with a few exceptions that I'll point out now. So, as I mentioned, every propositional letter has exactly one verifier and exactly one falsifier. We assume that there is a null state, which is the only verifier of the top proposition. Negation is standard, as in the bilateral semantics. And then conjunction and disjunction are standard, but remember that there is more than one way, more than one standard way to handle disjunction and to handle conjunction. And specifically, there is a distinction between inclusive and exclusive clauses for disjunction, where the difference is that on the exclusive variant of Truthmaker Semantics, a truthmaker for a disjunction must be a truthmaker for one of the disjuncts. Whereas on the inclusive clause, it can also be the fusion of a truthmaker for the first disjunct with one for the second. Likewise, on the false making side, we have these two options for the false makers of conjunction. And so it might seem perverse to make different choices on the disjunction side and on the conjunction side, but we are leading into that perversion, so to speak, because we are using this degree of freedom together with the fact that we're using a negation that is non-classical and that therefore gives us the way to exploit this degree of freedom to model the difference between disjunctive antecedents and negated conjunctive antecedents that I laid out at the beginning. So because we have put the non-standardness from the classical propositional logic point of view into the Truthmaker semantics, we are now free to keep the standard, or at least in spirit, the standard Katzer-Lewis semantics. For the clauses for the conditional modals, what we're going to do is essentially this. We're going to go through each way that the antecedent can be true, each truthmaker of the antecedent. Each such truthmaker, let's call it T, will generate an anchor state together with the consequent. And then we're going to sum up all these anchor states. And that's going to be our truthmaker for if phi, then box psi. And then if phi, for if phi, then box psi. And then as for if phi, then diamond psi, we're going to do the same exact thing, except we're swapping out the anchor function. On the false making side, we're reusing these anchor functions. So we have only 2 anchor functions and not 4. And we're, as far as I can tell, we really do need 2. We can't have just 1 anchor function. Ask me about that in the question period if you're curious. And so in this way, what we do is that for each modal statement, we have a single truth maker and a single falsity maker, which is obtained from summing up all the truth makers or falsity makers for all of the modal anchors that you get by cycling through the different ways that the antecedent can be true, the different truth makers for the antecedent. So when you have one antecedent that has only 2 truth makers, like not A or not B, and another one that has 3, like not both A and B, and that's the effect of the perversion that I introduced before, well, then you will have different truth makers for the entire modal conditional that uses these 2 different antecedents. And that's how we get the difference in truth conditions as a result of a hyper-intentional but not truth conditional difference in the antecedent. But we get the difference in truth conditions for the entire conditional. For comparison, these are the truth conditions in a Katzer classical model. And then now we have introduced a number of changes to the Katzer-Lewis story. And so you might wonder, is it really justified to make the claim, as I have made, that we are keeping the spirit of the Katzer-Lewis semantics, well, I am putting forward a theorem which is essentially true by design, in support of my claim that yes, we are justified in doing so, which is this. Consider any definite proposition, which is to say any proposition that has exactly one truth maker. Consider any two such definite propositions, phi and psi. And in our framework, that will include any proposition which is any literal, so any propositional letter, any negation of a propositional letter, and also any conjunction of two literals, for example. But it will not include disjunctions, crucially. And so, for any two definite propositions, if you put them together with a modal connective, then the result will be true in a Katzer truthmaker model if and only if it is true in what I'm calling the corresponding Katzer classical model. Because the corresponding Katzer classical model is a model that has the same f and g, so the same functions from worlds to sets of worlds, and whose valuation essentially does the same thing. And so in particular, this holds for box phi, because that's just a shorthand for if true, then must phi, and true is also definite. And so now, if you go back and you look at the motivating examples that Katzer uses in her classic papers from 1981 and 1991, where she develops and puts forward what is now the standard analysis of modals and conditionals, well, all of these examples involve definite antecedents and consequence and prejacents. They're all definite. So that means that our account agrees with her account in its predictions for all of the examples that motivated that standard analysis. It's only where the only places where the accounts diverge are precisely those where arguably it has to diverge, namely those kinds of data that I started out with that are a problem for the standard Katzer-Lewis analysis as stated in the original papers. But these turn out now on reflection based on our, let's say, friendly amendments to the framework, not to be a problem, so long as you're willing to accept truthmaker semantics instead of classical propositional logic. But then who here wouldn't? So specifically, we replicate the baseline in that, so by the baseline, I mean the data set from the Katzer 1981 paper. So, for example, as in the case of Katzer, we don't have explosion as a result of inconsistent laws. So her example is murder. So let's say there's two laws, and one says that goat owners are liable for damage, and one says that goat owners are not liable for damage. And then you have another law that says murder is a crime. And just because the law is inconsistent in the case of goat owners, you don't want to conclude that anything goes with respect to murder. So this is standard deontic logic and classical cryptic semantics famously gets this wrong. And it's one of the selling points of many semantics of deontic logic, including the Katzer-Lewis semantics, that it doesn't get this wrong. And so because all of these propositions are definite, all of these are definite prejacents, we have the same predictions as Katzer does. Similarly, practical inferences. This is a story where we are talking about what someone should or should not do based on their desires and the relevant facts, meaning the constraints on accessible worlds. So someone, we imagine, wants to become the mayor and also wants to avoid going to the pub, but unfortunately, you become the mayor only if you go to the pub. For some odd reason, you also go to the pub only if you become the mayor. I don't know why, but no, that's not essential. But so the important thing is, suppose that person, in addition to these inconsistent desires, also wishes to go hike in the mountains. Then from the mere fact that there are some inconsistent desires somewhere, in this case they are inconsistent not logically, but only given the modal base, we should not thereby conclude that everything is true with respect to whether they should hike or not hike, or whether they may hike or not hike. And so Katzer gets this nicely right, and we do too. Same for the Samaritan paradox. Chisholm's paradox is not something that Katzer talks about in her classic papers, but I just wanted to bring it up since you can't really talk about deontic logic without saying something about Chisholm's paradox. In fact, it's odd that she doesn't bring it up because she has something to say, or her account has something to say about it. So her account predicts no inconsistency between the premises of Chisholm's paradox. And so neither do we, because these premises all involve definite propositions. So now where we improve on the baseline is, first of all of these cases involving complex antecedents, complex consequence, complex prejacents. And so the way that we handle antecedents and consequences is a little bit different. For the antecedents, we go through each truth maker for the antecedent, and we generate a modal state for that truth maker only, and then we sum them all up. And so that essentially then allows us to distribute over the parts of the complex modal state and get back to the individual truth makers, or the modal states for the individual truth makers of the antecedents. For consequence and for prejacents of modals, we use this addition to the Katzer clauses that I described earlier, where instead of, or in addition to saying, well, at every best accessible world, some truth maker for the prejacent / the consequent obtains, we also say, well, every truth maker for the prejacent or the consequent is part of some best accessible world. And this second clause gives us free choice, gives us Ross's so it blocks Ross's paradox, blocks the inference known as Ross's paradox, because, well, suppose you ought to post the letter. Well, that means every best world makes it true that you ought to post the letter. But that doesn't not mean that for a proposition where one of the truth makers is you burn down the building, that every best accessible world has a truth maker for you burn down the building. And in an intended model, none of them will. Let's go through SDA. So if A or B, then must C. So suppose that that's true at a world, and that the truth makers for A and B are little a and little b. So then by a fairly direct application of the interpretation clauses for if A then for if phi then must psi, at the world where the conditional as a whole is true, its truth maker is true. It has only one. That truth maker is a fusion of a truth maker for if A then must C with a truth maker for if B then must C. And so if the fusion of these two truth maker obtains, then each of them obtains. If the fusion is a part of the world in question, then each of them is a part of a world in question. And so by transitivity of parthood, then also the truth maker for if A then must C is part of the world. And so if A then must C is true at that world. So again, it's a very direct application that results from the fact that we feed each truth maker for the antecedent separately into the function that generates our modal states. Remember that double SDA was an invalid inference. That's the inference from if not A or not B, then C, to if neither A nor B, then C. So we want to invalidate this, but we want to validate the corresponding inference from if not both A and B, then C, to if neither A nor B, then C. And so the way we do it is, again, by leveraging the degree of freedom that we have in the clauses for verification, falsification of conjunction and disjunction. These clauses are designed so that the disjunction of negations, namely not A or not B, has two verifiers. But the negated conjunction, not both A and B, has a third verifier as well, which is a fusion of the first and the second. And so as a result, there is one more way that the negated conjunction can be true. So one more truth maker that we feed in turn. We feed each of these truth makers in turn into the function that generates modal anchors for us. And so as a result, we get distribution only two ways in the case of disjunctive antecedents, but three ways in the case of negated conjunctive antecedents. Negative free choice is valid in a way that is essentially similar to the way that ordinary free choice is valid. We this time generate, I think I'll skip that for reasons of time. And then just a standard pedestrian case of free choice permission, you may A or B. Let's step through that. So assume it's true at a world and that the two disjuncts have only one verifier each. So then that means that the modal state that this world contains, the modal state that anchors the proposition that has just these two verifiers, A and B, and that contains a null state because we don't have an overt conditional antecedent here. So if true, then may A or B is what this underlying is analyzed as. And so now the second clause of the two clauses of Katzer Truthmaker frames, that was a clause that we've added. First clause just says, well, some best accessible world contains a truth maker for this proposition. So some best accessible world either contains A or contains B. But the second clause is what we've added. That says, well, A is part of some best accessible world and B is part of some best accessible world. Okay. But then, since A is part of some best accessible world, well, then there has to be also in that world, so this world must also contain a modal anchor for the singleton of that proposition. So we've ensured in our definition of the Katzer Truthmaker frames that whenever the corresponding modal, whenever the accessible worlds in question contain the right truth makers, then a modal anchor obtains. And if and only if they contain the right truth makers, then a modal anchor obtains that records this fact. We're stipulating this correlation essentially. And so because this correlation goes both ways, from the fact that A is part of some best accessible world, we can infer that the world of evaluation contains a modal anchor for the singleton of that fact, for the singleton of that truth maker. And so from this then, we know that UMA has a truth maker in the world of evaluation. So we've gotten from UMA A or B to UMA A. We've used only the clause number 2 of we've crucially used the clause number 2 of the Katzer Truthmaker frames. That clause is the same for boxes and for diamonds. And so the way we get free choice from obligation is the same exact way as how we get free choice from permission. Free choice from obligation, remember, was the inference from you must A or B to you may A. Okay, so essentially what we've done so far is we've seen how the account applies to cases involving complex antecedents, complex consequence, and complex projacents. And we've seen that we're able to maintain the baseline. That is to say, we can let the Katzer-Lewis account operate essentially unchanged as far as its results are concerned, and I would argue as far as its spirit is concerned, whenever the propositions involved are all definite, whenever they all have just one truth maker. And as for those propositions that have more than one truth maker, we've leveraged the changes we've made to the Katzer-Lewis account to get the predictions that we wanted. The last thing I want to talk about is the modal gaps. So remember that modal gaps involve cases like smoking weed, which is neither explicitly permitted nor explicitly prohibited, and that they also involve cases where you have two actions. One of them is permitted, one of them is not. And then it's not true to say you may do this action or that action, but it's also not true to say you may not do this action or that action. So two kinds of ways in which modal gaps can arise. And so here, what I'll say very simply is a strategy we're using is that in bilateral truthmaker semantics, we can see to it that in certain cases, for a given statement, none of its truth makers obtains and none of its false makers obtains either. And of course, we want to manage this so that it only arises in those cases where we want to have it. And so the clauses are designed to manage it in the right way. But so we essentially generate absence of truth, and we can in fact generate falsity in those cases where we want it. That is a strategy that we use for those modal gaps that arise from disjunctions. For modal gaps involving strong permission, we have to add one more ingredient. And I would say that that is well motivated because in the literature on deontic logic, there is this well-recognized distinction between strong and weak permission, or explicit and implicit permission, as it's also called. And so the semantics that I've given so far, that I've just described as a semantics for permission, or more generally for existential modals, is going to be our semantics for weak permission. And as for our semantics for strong permission, what we'll do is it's weak permission with a twist. It's weak permission with an extra condition. So among the modal anchors for weak permission statements, we will identify a subset and we'll just label them. And these we will call the explicit permission statements, the states that verify explicit permission statements. So formally, we are introducing at each world a set of strong permission states, and we're also introducing a set of strong obligation states. And these will be subsets of the modal anchors for weak permission states and for weak permission statements and for weak obligation statements. And then we introduce a new connective for strong permission and a new connective for strong obligation. And the truth-making clauses, the verifying clauses for these connectives are going to be the same as they were for the weak connectives, with an additional conjunct that says, well, and the state has to be labeled a strong permission state. So it has to be in the subset designated as strong permission states, and correspondingly for strong obligation. On the false maker side, we don't change anything. And so what this means then is that we can have models in which a statement like Willem may smoke marijuana, where may is interpreted as weak permission, will be true. And at the same time, if may is interpreted as strong permission, the same sentence will be false, right? So depending on how the natural language expression may is disambiguated, whether it's disambiguated as a weak or as a strong operator in the same model, the same sentence will be true or false. And crucially, even as the same sentence can become false as a result of this this new operator, the dual sentence the negation sentence will not be affected by this manipulation, whether the modal is interpreted strongly or weakly, and that's because on the false making side, we are not making any changes to the semantics at all. So, in conclusion, I hope I didn't waste my time here in Munich. This has been part of what I announced that I would do as part of my grant proposal, and this has been what part of what I worked on while I was here. was a lot of fun, and it prompted me to learn a lot, not just about corners of Truthmaker Semantics I wasn't familiar with, but also about deontic logic. So what we have is a Truthmaker Semantics that's variably strict, just like the Katzer-Lewis semantics was variably strict. So it gives us a language, or the means to interpret a language in which we can talk about conditionals, about conditionalized modals, and of course about ordinary modals. And when it comes to these ordinary modals, we can handle the things that Katzer and Lewis can handle. We can avoid deontic explosion. We can avoid inconsistency in the case of Chisholm's paradox. When it comes to things that the Katzer-Lewis analysis doesn't do so well, or does in a way that's different from what we wanted to do, like validating simplification of disjunctive antecedents, blocking Ross's paradox, accounting for various cases of free choice obligation, free choice permission, and the like. We fare better and we make different predictions than the Katzer-Lewis predictions. And we do so specifically by leveraging the degrees of freedom that we get from Truthmaker Semantics, specifically from the ability to assign different semantics or non-analogous semantics to the verifiers for disjunction and to the falsifiers for conjunction. We are essentially now able to give semantics for conditional obligations, simply because we have now a language that makes this available to us. I also want to mention a few limitations of this approach, or a few ways in which we have consciously remained conservative from the Katzer-Lewis point of view, but perhaps a bit heretical from the Truthmaker Semantics point of view. We are still using possible worlds. We are even embracing a set of worlds notion of a proposition, though not when it comes to interpreting sentences in our language, but still our modal base and our ordering source, that is to say our conversational backgrounds, the devices that Katzer uses to determine accessibility and ranking of possible worlds. Well, these devices are unchanged for us. They are the same for us as they were for her. They continue to involve sets of worlds. So you might ask, is this necessary? And so, no, I don't think it's necessary. We've done this in order not to change too many things from the point of view of a criterion. Is it trivial to replace these sets of worlds by sets of truthmaker propositions? No. It raises a host of interesting questions. It gives new opportunities for partiality, because it may now turn out, depending on how you set things up, that a given world neither is nor is not accessible, or that the ranking becomes indeterminate in ways that it hasn't been able to be on the sets of worlds view. And so there's opportunities here to continue truthmakerizing this approach, so to speak. I have not have the opportunity to compare this approach either with Pietro's account that we heard yesterday, or with Dongwu's account that's been published last year, and that I think we're going to hear about later in the conference. And so I would be very interested in your thoughts on this comparison, how it compares. We have done things in Truthmaker Semantics that I think could have been done in other frameworks too, at least to a large extent. And specifically, I often found myself thinking that for many purposes, I may just as well have used inquisitive semantics. So this may well turn out to be true, or at least to be true when it comes to things in which, well, it may be true on balance. So I'll stop here. Thank you very much for this opportunity to present, and thank you for coming to the conference.